Hey guys, we're back. We're doing question 24 from 9.2. It's got a more specific name, but really generally we're just going over the area of how we find the area of polygons in the coordinate plane. So if I pull up my presenter here, so I've got this polygon drawn. It's from question 24 that was highlighted back there, and we see that these two sides are parallel to each other. So I can actually notate that they're parallel to each other with arrows, but these two sides are definitely not. And because they're at a different angle, I can go ahead and assume that this is not an isosceles trapezoid. So what I have here is just some awkward trapezoid. But I know that the area formula for a trapezoid is the average of the bases times the height. But I need to turn this to actually look at what is the base and what is the height. So we see that this right here is actually our first base. And this side on top is our second base because they have to be parallel with each other. So I'm going to take the average of those two lengths and then multiply by the height. But I need to determine what the height is first. So the height has to be the vertical perpendicular distance between the bases. So that will be our height. So I'm going to go ahead and pause the video while I find out all those values and set up our work. Alright, so I went ahead and found out that this base on the what was our bottom when we had this rotated was 13. Our height, the distance between the bases, was 6, and our second base here is 8. So then I go ahead and plug all that into our formula and say that to average my bases, I'm going to sum the two bases and then divide by 2. Then I multiply by the height, which is 6. So then I move on. Now this gets a little messy because this turns into 21 divided by 2 times 6, and since 21 doesn't divide by 2 very nicely, I'm just going to go ahead and actually say instead of doing 21 divided by 2, that's really like 21 times a half, so I'm going to use my commutative property to move some things around and just say really this is a half times the 21, but I'm going to put that out here and move the 6 here because half of 6 is way easier than half of 21. So then half of 6 is 3 multiplied by 21 gives me my final answer of 63 units squared. Now that's the way to solve it using the trapezoid area method, but there is another way. So if we look at this shape again and really see what do we see when we look at the shape, I see what could be a right triangle over here, a rectangle in the main middle area, and another right triangle that actually is already made for me using the x-axis. So I'm going to box this stuff out. Talking about this triangle here, talking about this triangle here, and then talking about this rectangle inside right here. So the other method that we could use to solve for this area is just breaking up the shape into other multiple shapes and using our triangle formula of 1/2 times the base times the height, making sure that the base and the height both have to be perpendicular. So here I'd have a base and a height, and of course I'm not going to solve this all the way out for you because you could do this. I'd have my base and my height, and of course that would not have the 1/2 involved in it since it's a rectangle, and then I have a base and a height. So there's the other method that we could use for solving the area of that trapezoid. This one, I forget who asked the question, but if you are still struggling at all, please let me know. I am also going to make a video for question 28 to help you out on that one.